Right, this next example is going to talk about writing either a number or a polynomial or a larger polynomial, higher degree polynomial in terms of its factors. And we've already done this. Back in, I think, 5th or 6th grade, you were asked to make factorial trees for 42 and find all of the prime factors of 42. And the very first thing you did was you noticed that 42 is an even number, and so you divided it by 2. And you got 2 times 21. And what are the factors of 21? Well, you know that 21 is 3 times 7. And these were all called leaves. And when your leaves were prime, which means no other numbers could go into them, you found all your factors. So you could rewrite the number 42 as 2 times 3 times 7. Okay, and that was the same as writing the number 42. And then I think it was in the last chapter we talked about how to factor a polynomial, right? We learned that if you have a polynomial, a quadratic polynomial in particular, you could take a look at this last number here and look at the 4 factors of 6. Ooh, let's change this because there are none. This really should be a negative. Factors of -6 that add up to a positive 1. And we know the factors of -6 that add up to a positive 1 is a positive 3 and a negative 2. And so we rewrote this polynomial in terms of its factors, x plus 3 and x minus 2. Okay, so then we took a look at something like this and we learned how to factor it by grouping. But this is kind of a really large polynomial and it doesn't really factor real nicely. So let's take a look. What would happen if I told you what one of the factors were? How could we factor this a little bit easier? Well, we could set up, because this is a linear factor, it has degree 1, we could take a look at this polynomial and divide it by its factor. So let's set up the synthetic division. Because it is linear, let's set up a synthetic division problem. What are we going to put inside of our little box there? X plus 5 equals 0, so x is going to be -5. All right, we're going to stick -5 in our box. What are all of our coefficients? We don't have any missing terms, so we're going to write a 1, a 7, a -38, and a -240. Let's go ahead and bring our 1 down and do synthetic division to see what other polynomial, if we multiply this by another polynomial, what would it be? Okay, so -5 times 1 is -5. When we add these two, we get a 2. 2 times -5 is -10. When we add these two, we get a -48. -5 times -48 is a positive 240, and when we add these, we get a 0. So x plus 5 is definitely a factor. We have a remainder of 0, so therefore it definitely is a factor. So let's go ahead and build our quotient polynomial. It's going to be x squared plus 2x minus 48, and that, if we multiply it by x plus 5, are the factors of x cubed plus 7x minus 38x minus 24. But are all of our factors prime? And I'm thinking that this one can be factored again. So let's see. We know this one's prime because it's linear, but let's take a look at this one. Are there factors of -48 that add up to a positive 2? -48 and 2. Let's see. How about if we do a positive 8 and a -6? That multiplies to -48 and that adds to 2. So we can actually factor our quotient polynomial, x plus 5, into 2 factors. We can factor it into an x plus 8 and an x minus 6. Okay, these are all the factors of our polynomial, and we determine them by using synthetic division.